Welcome to our Class 10 Quick Revision session. In this video, we'll cover the most important concepts you need to know, helping you revise faster and smarter. Whether you are preparing for exams or just brushing up on your knowledge, we've got you covered. Let's get started and make learning easy and efficient. The chapters of Class 10 Physics are Light, Reflection and Refraction, Human Eye and Colorful World, Electricity and Magnetic Effects of Electric Current. In the first chapter, we explore how light behaves when it bounces off surfaces and bends when passing through different mediums. You'll learn about mirrors, lenses, and the formation of images. Light exhibits dual nature. It acts as both a wave and a particle. Light is a form of electromagnetic radiation. It travels through space as oscillating fields. These are perpendicular electric and magnetic fields. Reflection is the bouncing back of light when it strikes a surface. It follows these rules. First law of reflection states that the angle of incidence is equal to the angle of reflection, where angle of incidence is the angle between the incident ray and the normal to the surface. Angle of reflection is the angle between the reflected ray and the normal. Second law of reflection states that the incident ray, reflected ray, and the normal all lie in the same plane. There are three main types of mirrors. First, plane mirror. It is a flat, smooth mirror with a reflective surface. It produces virtual, upright images that are the same size as the object and appear to be the same distance behind the mirror as the object is in front. The images are laterally inverted. It is commonly used in households, optical instruments, and periscopes. Second one is the concave mirror. It is a mirror with an inward curved reflective surface like the inside of a sphere. It converges incoming light rays to a focal point. Depending on the object's position, it forms real and inverted images are formed when the object is beyond the focal point. Virtual and upright images are formed when the object is between the focal point and the mirror. It is used in telescopes, shaving mirrors, makeup mirrors, and headlights to focus light. Third one is the convex mirror. It is a mirror with an outward curved reflective surface like the outside of a sphere. It diverges incoming light rays, making them appear to originate from a point behind the mirror. It always forms virtual, upright, and smaller images regardless of the object's position. It is used in vehicle side mirrors and security mirrors for a wider field of view.
Next is mirror formula. The mirror formula is 1 by f is equal to 1 by u plus 1 by v,
where f is the focal length, u is the object distance, and v is the image distance. Magnification of mirrors, m is equal to minus v by u. If m is greater than 1, the image is magnified. And if m is less than 1, the image is diminished. Next is refraction. It is the bending of light as it passes from one medium to another with a different refractive index. This change in speed causes the light ray to change its direction. Why does refraction occur? Refraction occurs because light travels at different speeds in different media. Laws of refraction. Snell's law. The ratio of the sine of the angle of incidence to the sine of the angle of refraction is constant and equals the ratio of the refractive indices of the two media. When light passes from a less dense to a more dense medium, it bends towards the normal. When light passes from a more dense to a less dense medium, it bends away from the normal. Lenses are transparent optical devices that refract light to either converge or diverge it. They are commonly used in eyeglasses, cameras, microscopes, and telescopes. Types of lenses. 1. Convex lens or converging lens. A convex lens is thicker in the center and thinner at the edges. It converges parallel rays of light to a single point called the focus. Depending on the object's position, it can form both real and virtual images. 2. Concave lens or diverging lens. A concave lens diverges parallel rays of light, making them appear to originate from a focal point behind the lens. It always forms a virtual, upright, and smaller image. Lens formula and power of a lens. Lens formula is 1 by f is equal to 1 by v minus 1 by u. It relates object distance, image distance, and focal length. Similar to mirror formula, the lens formula is used for the calculation of image distance, object distance, and focal length of convex lens and concave lenses. Power of a lens is the reciprocal of the focal length of the lens. P is equal to 1 by f. If the focal length is given in centimeter, use the equation as 100 divided by f. Power of a lens is the ability to converge or diverge light rays. It is measured in diopter. It is essential for eye vision corrective lenses. Convex lens has positive power and concave lens has negative power. Real-world applications of lenses. Convex lenses are used in cameras, microscopes, projectors for image formation and for hypermetropia. Concave lenses in glasses for myopia. Combination of lenses in telescopes and binoculars for clear magnified vision. Alright, let's go through some numericals. An object is placed 20 centimeters in front of a concave mirror with a focal length minus 10 centimeters. Find the image distance using mirror formula. To find the answer, use the mirror formula 1 by f is equal to 1 by v minus 1 by u. Here focal length and image distance of a concave mirror are negative. So 1 by minus 10 is equal to 1 by v minus 1 by minus 20. So v is equal to minus 20 centimeters. The image is formed 20 centimeters behind the mirror. Next question. A convex lens has a focal length of 25 centimeters. Calculate its power in diopter. Power P is equal to 100 divided by f. So, it is equal to plus 4 diopter. The power is positive in the case of convex lens.
The second chapter of Class 10 Physics is The Human Eye and the Colorful World. This session explores the fascinating world of human vision. We will delve into the structure of the eye, how we perceive color, and common vision defects. We'll also look at how lenses correct these defects. Finally, we will cover the dispersion of light and the beautiful phenomenon of rainbow formation. Human eye. The human eye is roughly spherical in shape with a diameter of about 2.3 centimeters. It consists of a convex lens made up of living tissues. Hence, human lenses are living organs contrary to the simple optical lenses. The following table lists the main parts of the human eye and their respective functions. Parts of human eye. Retina. It is a light-sensitive screen inside the eye on which image is formed. It contains rods and cones. Cornea. It is a thin membrane which covers the eye trail. It acts like a lens which refracts the light entering the eye. Aqueous humor. It is fluid which fills the space between cornea and eye lens. Eye lens. It is a convex lens made of transparent and flexible jelly-like material. Its curvature can be adjusted with the help of ciliary muscles. Pupil. It is a hole in the middle of iris through which light enters the eye. It appears black because light falling on it goes into the eye and does not come back. Ciliary muscles. These are the muscles which are attached to eye lens and can modify the shape of eye lens, which leads to the variation in focal lengths. Iris. It controls the amount of light entering the eye by changing the size of the pupil. Optical nerve. These are the nerves which take the image to the brain in the form of electrical signals. Rods and cones are specialized cells in the retina that detect light and help you see. Rods are responsible for night vision, while cones help you see color and fine details. Common vision defects. Myopia. Nearsightedness. Individuals with myopia can see nearby objects clearly, but distant objects appear blurry. This occurs when the eye's shape causes light rays to bend incorrectly, focusing images in front of the retina instead of on it. Hyperopia. Farsightedness. In hyperopia, distant objects are seen clearly, but nearby objects appear blurred. This is because light rays are focused behind the retina instead of on it. Astigmatism. Astigmatism causes distorted or blurred vision at all distances because light rays entering the eye do not focus evenly onto the retina. This is often due to an irregularly shaped cornea. Presbyopia. This age-related condition makes it difficult to focus on near objects, requiring individuals to hold reading materials further away. Myopia and hyperopia are corrected with concave and convex lenses, respectively, while astigmatism requires cylindrical lenses, and presbyopia often needs bifocal lenses. Refraction of light through a prism. When light refracts through a prism, it bends due to the change in speed as it enters and exits the prism. The light bends towards the normal when entering the denser medium, prism, and away from the normal when exiting into the rarer medium, air. This bending causes the emergent ray to deviate from the original incident ray, and the angle of deviation is the difference between the emergent and incident ray angles. Refraction of light through a glass slab. When a ray of light is incident on a rectangular glass slab, after refracting through the slab, it gets displaced laterally. As a result, the emergent ray comes out parallel to the incident ray. The angle of emergence is the angle at which light comes out of a medium. Recombination of white light. Isaac Newton was the first who obtained spectrum of sunlight by using glass prism. He tried to split the spectrum of white light more by using another similar prism, but he could not get any more colors. He repeated the experiment using second prism in inverted position with respect to the first prism. It allowed all the colors of spectrum to pass through second prism. He found white light emerges on the other side of second prism. Next topic is dispersion of light. Dispersion of light is the phenomenon where white light splits into its constituent colors when it passes through a transparent medium like a prism. This happens because different wavelengths of light are refracted at different angles as they pass through the medium, causing them to separate. Rainbow formation. A rainbow is a natural spectrum appearing in the sky after a rain shower. It is caused by dispersion of sunlight by tiny water droplets present in the atmosphere. A rainbow is always formed in a direction opposite to that of the sun. The water droplets act like small prisms. They refract and disperse the incident sunlight, then reflect it internally, and finally refract it again when it comes out of the raindrop. Due to the dispersion of light and internal reflection, different colors reach the observer's eye. Next, atmospheric refraction. The refraction of light caused by the Earth's atmosphere, having air layers of varying optical densities, is called atmospheric refraction. Appearance of star position. It is due to atmospheric refraction of starlight. The temperature and density of different layer of atmosphere keeps varying. Hence, we have different medium. Distant star act as point source of light. When the starlight enter the Earth's atmosphere, it undergoes refraction continuously, due to changing refractive index from rarer to denser. It bends towards the normal. Due to this, the apparent position of the star is different from actual position. The star appear higher than its actual position. Twinkling of star. It is also due to atmospheric refraction. Distant star act like a point source of light. As the beam of starlight keeps deviating from its path, the apparent position of star keeps on changing because physical condition of Earth's atmosphere is not stationary. Hence, the amount of light enters our eyes fluctuates, sometimes bright and sometimes dim. This is the twinkling effect of star. Why planets do not twinkle? Planets are closer to Earth and are seen as extended source of light, a collection of large number of point-sized sources of light. Therefore, the total amount of light entering our eyes from all individual point source will nullify the twinkling effect. Scattering of light, Tyndall effect. When a beam of light encounters minute particles in the Earth's atmosphere, such as suspended dust and air molecules, the path of the beam becomes visible. This phenomenon, where light is scattered by these colloidal particles, is known as the Tyndall effect. A common example is the visibility of sunlight as it passes through the canopy of a dense forest. The third chapter in Class 10 Physics is electricity. Next session provides a quick revision of key electricity concepts. From electric charge to circuit power, we'll cover essential principles in just few minutes. Electric charge. Electric charge is a fundamental property of matter that allows it to experience a force when placed in an electric field. It's the reason why some objects attract or repel each other when brought close. There are two main types of electric charges: positive charge and negative charge. Positive charge, primarily carried by protons, which are found in the nucleus of atoms. Negative charge, primarily carried by electrons, which orbit the nucleus of atoms. Important terms in electricity. Voltage is the electrical potential difference that drives the flow of electrons, while current is the actual flow of electrons. Voltage is measured in volts, and current is measured in amperes. Resistance is the opposition a material offers to the flow of electric current, and is measured in ohms. Ohm's law. Ohm's law states that at constant temperature, the current flowing through a conductor is directly proportional to the potential difference across it, with the constant of proportionality being the resistance. Mathematically, this is represented as V equals IR, where V is voltage, I is current, and R is resistance. Main applications of Ohm's law is to determine the voltage, resistance, or current of an electric circuit.
Series and parallel resistance circuits. In series circuits, resistors are connected end to end. The same current flows through each resistor. The total resistance is the sum of the individual resistances. The voltage drop across each resistor is different. Components connected along a single path. The current is constant. In parallel circuits, resistors are connected so that they share two common nodes. The same voltage is applied to each resistor. The current through each resistor may be different. The total resistance is less than the lowest resistance of any of the components. Components connected along multiple paths and the voltage is constant. The total resistance in a series circuit is the sum of individual resistances. The total resistance in a parallel circuit is less than the smallest individual resistance. If 5 resistors each of value 0.5 ohm are connected in series, what will be the resultant resistance? The total resistance is the sum of the individual resistances. Therefore, total resistance is 2.5 ohm. Next question. If 5 resistors each of value 5 ohm are connected in parallel, what will be their total resistance? The equivalent resistance is as per the equation of parallel resistors is 1 ohm here. Next, power in electric circuits. Power is the rate at which electrical energy is transferred. Power is measured in watts. Formula of power is equals to voltage times current. Power P equals VI. 1 watt is equal to 1 volt into 1 ampere. 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joule. Another form of equation of power is I square R. Power equals current squared times resistance. Power in terms voltage and resistance is V squared divided by R. Next, numericals of the topic power. First question. An electric bulb is connected to a 220 V generator. The current is 0.50. What is the power of the bulb? Use the formula P equals VI to calculate the power. P equals 220 volt into 0.05 ampere equal to 110 watt. Next question. An electric refrigerator rated 400 watt operates for 8 hours per day. What is the cost of the energy to operate it for 30 days? At 3 rupees per kilowatt hour. It is given that the electric power of the refrigerator equals 400 watt. The time for which it is used on a daily basis equals 8 hours. The number of days for which it operates equals 30 days. Thus, from the formula of electric energy consumed, energy equals power times time times days. Energy equals 400 times 8 times 30. Energy equals 96,000 watt-hour. Hence, the total energy consumed after 30 days is 96 kilowatt-hour. It is given, cost per kilowatt-hour is 3 rupees, therefore, the total cost after 30 days will be equals 96 times 3 equals 288 rupees. Fourth chapter in Class 10 Physics is Magnetic Effects of Electric Current. This chapter uncovers the relationship between electricity and magnetism. This section introduces the fundamental concepts of magnetic fields produced by electric currents. We will explore the visualization of these fields, the rules governing the direction, and the practical applications of electromagnets. Visualizing magnetic fields and field lines. Magnetic fields are areas where magnetic forces are present. Magnetic field lines represent the field's direction and strength. A higher density of lines indicates a stronger field. Direction. Magnetic field lines originate from the North Pole. Magnetic field lines terminate at the South Pole. Strength. Closely spaced field lines indicate a strong magnetic field. Widely spaced field lines indicate a weak magnetic field. Right-hand thumb rule. Field direction. This rule helps determine the magnetic field direction. Grasp a current-carrying conductor with your right hand as shown in the figure. Your thumb points in the current's direction. Curled fingers indicate the magnetic field's direction. Magnetic field lines form concentric circles. Fleming's left-hand rule. Fleming's left-hand rule shows the force on a conductor. This happens in a magnetic field when carrying current. Extend your thumb, forefinger, and middle finger as shown in the picture. Forefinger points in the direction of the magnetic field. Middle finger shows the direction of the current. Thumb indicates the direction of the force. Magnetic field due to a current through a straight conductor. The magnetic field around a long, straight conductor carrying an electric current is made up of concentric circles. The strength and direction of the magnetic field can be calculated using the right-hand rule. The magnetic field strength decreases as the distance from the wire increases. It can be noticed that the concentric circles representing the magnetic field around a current-carrying straight wire become larger and larger as we move away from it. Magnetic field due to a current through a circular loop. The magnetic field lines form concentric circles around the loop. At the center of the loop, the field lines are straight and perpendicular to the plane of the coil. The direction of the magnetic field can be determined using the right-hand thumb rule. The magnetic field intensity increases as the electric current increases. It also decreases as the radius of the loop increases. The current-carrying circular loop behaves like a magnet. Next important topic is magnetic field due to a current in a solenoid. A coil of many circular turns of insulated copper wire wrapped closely in the shape of a cylinder is called a solenoid. A current in a solenoid produces a magnetic field similar to a bar magnet. The magnetic field lines are parallel and run from the North Pole to the South Pole. When the current flows clockwise, the face of the coil acts like a South Pole. When the current flows counterclockwise, the face of the coil acts like a North Pole. How is the magnetic field produced? A solenoid is a coil of wire that's tightly wound in a helix. The diameter of the solenoid is smaller than its length. The magnetic field is produced when electric current flows through the coil. How can you increase the magnetic field? By increasing the number of turns in the solenoid. By increasing the strength of the current and also use a soft iron core along the axis of the solenoid. You can use a solenoid's magnetic field to magnetize a piece of magnetic material. The magnet so formed is called an electromagnet. Magnetic field due to a current through a circular loop. The magnetic field lines form concentric circles around the loop. At the center of the loop, the field lines are straight and perpendicular to the plane of the coil. The direction of the magnetic field can be determined using the right-hand thumb rule. The magnetic field intensity increases as the electric current increases. It also decreases as the radius of the loop increases. The current-carrying circular loop behaves like a magnet. Next, electromagnet. A strong magnetic field produced inside a current-carrying solenoid can be used to magnetize a piece of magnetic material like soft iron by placing it inside the coil or solenoid. The magnet so formed is called an electromagnet. The magnetic field, produced with the flow of an electric current in a magnet, is known as the electromagnet. It usually consists of a wire wound in a coil, and the current through the wire creates the magnetic field, which is concentrated in the hole, representing the center of the coil. Electromagnets use electricity to create magnetic fields. These fields can be turned on and off. They can generate very strong magnetic fields. This is useful for heavy lifting. Force on a current-carrying conductor in a magnetic field. A current-carrying conductor produces a magnetic field around it. It behaves like a magnet and exerts a force when a magnet is placed in its magnetic field. Similarly, the magnetic field also exerts equal and opposite force on the current-carrying conductor. When an electric current is passed through the conductor by switching on the plug key, the conductor moves away from the horseshoe magnet, indicating that the force from the magnet is acting on the conductor. Now, if the polarity of either battery or the horseshoe magnet is reversed and the electric current is passed, then the conductor will move towards the magnet, indicating the direction of the force is reversed. The direction of this force can be determined using Fleming's left-hand rule. According to the rule, the forefinger and the center finger of a stretched left hand point in the direction of the magnetic field and the electric current respectively, while the thumb points in the direction of motion of force acting on the conductor. Domestic electric circuits. The electric power to a house is supplied either through overhead wires or through underground cables. The cable has 3 separate insulated wires. The live wire has usually red insulation cover, neutral wire has black insulation cover, and the earth wire has green insulation cover. As per the new international convention, live wire has brown-colored insulation cover, whereas neutral and earth wires have light blue and green insulation covers. The potential difference between the live and neutral wire is 220 volt. The neutral and the earth wires are connected together at the local substation so that both of them are at zero potential. Numericals. 1. An electric oven of 2 kW power rating is operated in a domestic electric circuit, 220 volt, that has a current rating of 5 ampere. What result do you expect? Explain. Power P equals V times I. I equals PV equals 2000 times 220 equals 9 ampere. The current drawn by this electric oven is 9 ampere, whereas the fuse in the circuit is only 5 ampere capacity. When a high current of 9 ampere flows through the 5 ampere fuse, the fuse will get heated too much, melt and break the circuit. Therefore, when a 2 kW power rating electric oven is operated in a circuit having 5 ampere fuse, the fuse will blow off, cutting off the power supply in this circuit. Next question. An electron enters a magnetic field at right angles to it, as shown in figure. The direction of force acting on the electron will be A. To the right, B. To the left, C. Out of the page, D. Into the page. Answer is option D. The direction of force is perpendicular to the direction of magnetic field and current, as given by Fleming's left-hand rule. Recall that the direction of current is taken opposite to the direction of motion of electrons. The force is therefore directed into the page. Thanks for watching. Please subscribe this channel for new physics videos.